The world's fastest against the world's strongest. What am I working out? The amount of chemical energy that flows from Usain Bolt's muscles into his motion, compared to the amount of chemical energy that flows from Zydranis Savickas' muscles into the Earth's gravitational field when he does a log lift. Specifications. Usain Bolt's mass is 94 kilograms, the displacement is 100 meters, and the change of time is 9.58 seconds. The mass of the weights that Zydranis Savickas lifts is 226.796 kilograms. He lifts them 2.546 meters high, in 6.43 seconds. Physics representations. Usain Bolt's motion diagram shows that he speeds up. It also shows he's traveling in the positive direction, east. The velocity vectors show that he starts from rest and ends in motion. The displacement graph and the velocity graph show that the acceleration is constant. Zydranis Savickas' motion diagram shows that the weights move in the positive direction. The velocity vectors that the weights both start and end at rest. The velocity graph shows that the weights speed up in the middle of the lift but start and end at rest. The displacement graph paints the same picture. Physics representation 2. Usain Bolt has two interactions with the track, an applied and a normal, and he has one gravitational interaction with the Earth. The force diagram shows the normal and gravitational point opposite directions with the same magnitude, and there is also a horizontal applied force in the positive direction. Zydranis Savickas' interaction diagram system includes the weights and the Earth's gravitational field. It is just one applied interaction with Zydranis. The force diagram shows acceleration of the weights is upwards. Word representation. Usain Bolt runs in the positive direction, east. He's speeding up because he starts from rest and ends in motion. Zydranis lifts the weights in the positive direction, north. I'm assuming all acceleration are constant, and there is no friction or air resistance. Math representation. Work energy equation. External work equals the kinetic energy. Calculate the kinetic energy. Kinetic energy equals 1/2 times the mass multiplied by the velocity squared. Equals 1/2 multiplied by the mass times the displacement divided by the change in time, all squared. Equals 1/2 times 94 kilograms multiplied by 100 meters divided by 9.58 seconds all squared. Equals 1/2 multiplied by 94 kilograms times 10.44 meters per second squared. Equals 1/2 times 94 kilograms multiplied by 108.96 meters per second. Equals 5,121.142 joules. Now for Zydranis. The work energy equation is, external work equals gravitational energy. Calculate the gravitational energy. Gravitational energy equals mass times gravitational strength times the displacement. Equals 226.796 kilograms times 9.8 newtons per kilograms times 2.546 meters. Equals 5658.742 joules. Therefore, more chemical energy flows from Zydranis than Usain. Evaluation. The answer is reasonable, because while Usain Bolt sprints extremely fast, 226.796 kilograms is a lot of weight to pull 2.546 meters off the ground, and was expected to require more energy.